to you. Okay. Okay, good evening everyone. As a continuation for our Java learning, today's topic is sets. Okay, so in the previous session we have covered like list interface. So within the collection framework, so from the list interface we have seen the core concrete classes are array list, linked list, vector, and stack. So these are all the core concrete classes for the list interface. Now we will see for set interface. Okay, so it's also similar. So as we discussed yesterday, the collection itself is a like collection of elements, a group of elements. Okay, so of the same type actually. So the type we have defined by using the generics concept. So that's where like we have seen array list in the open and closed brackets. Like we have seen what is the type of the objects it is going to hold. So we have seen integer or string or any like other object also like so that's how like no we are defining. But similarly the object creation is there for the set and linking. So the comparatively the list between set is basically set will not allow the duplicate elements. So we have seen for the list it was allowing duplicate elements and also like uh, the order also it was providing. But when it comes for the set, by default it will not allow duplicate elements. Okay, so only one value will be present. So you cannot add the multiple values. Okay, with the same content. So that is the one thing. And another thing is by default it is not ordered collection actually. So it will not guarantee the order of the elements. So these are all the core concepts like we can see. So while choosing, so if you want like, so you have to store collection, I mean, array of objects. So in such cases, so based on the requirements, if you want to be only unique to elements, then you will choose a set or like your requirement wants like, no, it has to you allow the duplicate elements, then you will choose a list interface. Okay, so now we have mentioned that set does not allow duplicate value. So how it works internally is, so it uses the equals and hash code functions. Okay, so these are the two functions. Those are mandatory. I mean, internally those implementations are there. So I have shown you while going through the functions, right? Yesterday. So it is using like no equals function. It will use for the comparing the content. If the same content already something is present, it will try to override. So it will not keep as two elements. So that's how it checks for the duplicates. Okay. So in the first abstract set class is there. So from the set interface, there is a one abstract class which is providing the partial implementation for the set interface. That is abstract set. So this one, the hash code of a set is the sum of the hash code of all the elements in the set. Since the size method and the iterator method are not implemented in the abstract set class, abstract set is an abstract class. So it has provided many of the functions implementation, but it did not provide the size and iterator majorly. So those are still abstract. So that's why the class itself is became like a abstract class. Okay. So now see for hash set. Okay, as I've seen in architecture, so the hierarchy is there, right, from the collection framework. So I've seen from set, then abstract set. From abstract set, the core concrete classes are hash set, linked hash set, and tree set. So these are the core implemented classes. So let's see each one by one. Let's start with hash set. So the hashed class is a concrete class that implements a set interface. That's where like it's a fully concrete. So it can be used to store duplicate free elements. That's why I mentioned that it will not allow the duplicate elements. For efficiency, objects added to your hash set need to implement the hash code method in a manner that properly displays the hash code. So the thing is, it has to provide the implementation for the hash code and equals function, because the default implementation might not be that much effective. So it's always recommended, like, so better to go with our customized. Okay. So in the primitive and wrapper classes and all, it works fine, the existing one. But if you are going for your customized class, means that is outside of the Java. So class A or class student, these are all like no customized classes will tell. So in case you are going for any such object, you have to define equals and hash code function very clearly. Make sure that it will not provide any collisions. Okay. So that's where we should provide the proper implementation. So let's take equals function. How we do is, so if there are three fields in your class, you have to compare each field. Okay. If all are same, then only treat that as that object is same. So that's how, like, no, we need to implement the equals function. Okay. So this also supports iterator. So it's the same as like so for if you want to traverse through the set elements, or if you want to retrieve the set element, so that's where we will use the iterator. Okay, let's go for the example. Yeah, here is there one hash set. Okay, the most of the things are like no remains the same. So the functions, because few of the functions whatever we have seen from the collection interface, which is the parent of list and set. So what are the functions available in the collection from interface? Those are all applicable for the list implemented classes and set implemented classes. So that's how, see, I've created the object for the hash set. So I'm defining the type as integer. So I'm creating one hash set. So it will be containing the integer data type elements. Okay. Then I have added three elements. Let me add like even more. Numbers data add of 7. Okay. Then what I'm just printing it. Okay. Then I'm using the iterator. So I'm iterating through each element of the set and I'm printing it. Okay. That's how what I'm doing here. Let's execute this one and see. Yes, you can see. So it is printing the list of the elements. Okay. And so while iterating, so I can able to iterate through all these elements. So that is how it works. Let us work on another functions. So I'm adding some other elements to the set. Then I'm printing. So after that, I will try to remove some elements. Numbers dot remove. So I want to remove 10 from this. So system.out.println. Let's print size is. I'm just printing the size and retrieval is anyway it is there. So I can retrieve one more time. Okay. So at the end, I will clear it. So I will show you then another time. Yeah, if you see here, 2, 5, 6, 7, 8, then I have added, oh, 20 is so many times. Yeah, there is one example like I can treat as duplicates, right? So what I've done here, I have added 320s actually, okay? But I can see only 120 in my set. That's where, so whenever you try to add like, no, the last one, it overrides the existing one. So within that index, so whatever is there, so if you are giving the again, it will compare. So whether this value is already present or not. If it is already present, simply it overrides the value of it. That's it. It will not do anything. It will not add as a new entry. Okay. That is the one more thing. And if you see here, do you see any order here? So I have inserted 2, 5, 6, 7, 8, then 10, 20. So, but when I see the order here, 220, 5, 6, 7, 8, 10. So that's where I mentioned that. So hashed by default, it will not guarantee the order. Okay. So in case of the list, we have seen all the elements were listed through this insertion order. Okay. But in case of the hash set, the order is not guaranteed. Okay. Also, we tried to add the duplicate elements, but still we can see only one element in it. So these are the core features of the hash set compare with other. The size is 6 here, then I have deleted 10. So after deleting the 10, I don't see the 10 here, right? So 220, 5, 6, 7, 8. So here also the order does not guarantee. So it will give like any of the order. So it will not give any order, specific order actually. So that's it for hash set. So comparatively, if you see within the set implemented classes, so all the set works on does not support the duplicate elements. Okay, that is the core difference between list and set. Okay, then within that set implemented classes, which are there, has set, linked has set, and reset, there are differences are there. Like no, according to the requirements, which one to choose. So we'll see the difference wise. Now remember for this, in case of the has set, the order it is not guaranteed. Okay. So we have seen in the example. So now let's go for the linked hash set. Okay. Linked hash set. So this is also like the function wise, everything is similar for the hash set. The only thing is it is the backend structure is it is holding the linked list actually. Okay. So that's where the linked hash set. So there is a one array of elements are there. There's additional space for the linked list. Okay. So, and the one more difference is it guarantees the insertion order. Means whatever the order you insert the elements, it will guarantee in the same order elements will be retrieved. So in case of the hash set, there was no order, but in case of the linked hash set, order is guaranteed. Means insertion order. Okay. Let's say the example. So creation wise is the same. I have taken as integer data type. So if you see here, the collections will not work on the primitive data type. Okay. So primitive means like int, character, byte, short. So like this, whatever is there, these are all like no primitive type. So collection does not support primitive data type. That's why what they have done is they have introduced the wrapper classes. So wrappers are nothing but for the integer primitive data type, they have created one wrapper. This is a wrapper for character. This is a wrapper for integer. So like this for each type, they have created one wrapper classes. So to support for the collections. So how that works, that's why whatever I have defined the type here is the integer. It's not a small int actually. So while adding the elements, it will do auto boxing and unboxing. Okay. So that means it can convert from wrapper to primitive, primitive to wrapper automatically. So that JVM handles automatically. Okay. So that's why everywhere you can see only the wrapper type for the primitive types means predefined. And if you have the user defined classes, then anyway you will define like class A means you will define A here. So it's like that. So I created linked set object here. Then I have added 3 elements to it by using the add function. So 246. Then after that, what I'm doing, I'm just printing the elements from the linked set. So after that, what I've done, I've created one more linked set. So here only the even numbers I have added. Okay. So what I'm doing, I'm adding all the one of the linked hash to another one. So that's where we have seen the function, right? Add all. So if you want to add as a single object, so then we will use the add function. And if you want to add existing another collection to the another collection, we will use add all. So I'm having this event number set already. I want to add this complete set to another set. So that's where I achieve like this. Okay. Now my numbers is already having all the even number has set values means 246. Then again after that I have added the element 5. So then I'm printing the new linked hash set. So then what I'm doing, just like, see if you see here I have taken the array list. Okay. I have added 2 4. Okay. Again I'm adding that to the linked list. Okay. So 2 4 is already available. So we cannot see the difference. So let me go for 8 and 10. Let's execute now. What will be the output? We'll see. Yes. If you see the first here, even number linked hash set. So the elements I'm printing as 246. If you see here, it is 246. Okay. Then what I've done, I've created another linked list, which is the referenced as numbers, and I have added all these set values along with I have added 5 also. So if you see here, 246 and the 5. So this is how, if there is a one already known collection is there and you want to add that particular collection to another collection, that's where we use the add all function. Okay. So then what I've done, so here is a set to set type. So already one set existing set is there. I want to create another set and add all these set elements. That is done here. But when you see here, this is a list actually. So array list is a list implementing class. So again, from the list also, I can able to create set. So that is the example we are showing here. So array list elements are 8 10. From that array list elements, I have created one more linked hash set. So that is the elements are 8 10. So I have tried here set to set and list to set also. So there can be situations. So already list is there and I want to create set with that list. So you can achieve like this. Okay. And the traversal and all the things are like common. Okay. Deleting or getting and iterator. So all these functionalities are common, like whatever we have seen for asset, right? This is only the way like we will retrieve the elements. I can just show you that as well. Okay, numbers is already available. Let me execute this. Yes. If you see here, the order is there. Everywhere it is fixed. So what I'm doing, first 246. So the order is 246. And what I've done here, I have created numbers set. First I have added 246 to it. Then I have added 5. So let's see what it is containing. See, 2, 4, 6, 5. So that's how we are mentioning as linked hash set guarantees the order. Means it guarantees the insertion order. So the order, like how you added the elements, you can retrieve the elements in the same order. So here is the same thing. And again through iterator when I tried, there also I can see the order is the same, 2, 4, 6, 5. So that is a core difference between hash set and linked hash set. Hash set does not guarantee the order, but when it comes for the linked hash set, guarantees the order. So the order is insertion order. Okay. So these are the things about hash set and linked hash set. So within this set implemented classes, we are having the tree set as well. See, let's see what is this tree set. So tree set is a concrete class that implements a sorted set interface. You can use an iterator to traverse the elements in the sorted order. So if you see, so hash set, no order, linked hash set, insertion order, but when it comes for the tree set, the order is sorted order. Okay. So how it is sorting is, so it is internally used as a comparable interface. Okay. Within the comparable interface, there is a function called compare to function. So by using that function, it will compare between the objects and it will place the elements according to the order. Okay. So I will take this complete sorting as a separate topic. So what and all the ways are there, like how do you sort the elements and all. So as of now, just remember, so what is the background implementation and what is the ordering the tree set is supporting. Okay. Let's look for the example. See, tree set. Okay. So it's a similar like object creation everywhere. It is the same. It's a simple. So what I'm done, I have added 3 elements to the tree set. Okay. Then I'm printing the tree set. Then after that, like again, like I have created one more tree set. I've added one element and I have added so all the even numbers to this particular tree set. So it's nothing but there were different mechanisms are there. So instead always going for the add function, I thought of showing like no, so other functions supported things like add all, so that you can well aware of all these things practically. So that is the main reason why I have chosen like no multiple things. So this is the one iterator is the same. So there is a iterator function is there. So numbers.iterator if you call, it will return the iterator. So with through the iterator, like you can iterate each element. So has next is the one check for me. So if it is already there are the other next element is having, then only you print the next element. Otherwise, you return it. So let's execute this. Yeah. So 2, 4, 6 I have added. So for the first tree set, even numbers. So it is anyway printing 2, 4, 6. So if you see here, the elements I have added is those are already in the sorted order. Okay, means 2 I have added first, then 4, then 6. So that's why you don't see any difference here. So after that, I've created one more tree set. So here I've added the 1 first. Then I have added 2, 4, 6. Okay. Let's see what is the, see, the elements are showing in always sorting order. So 1, 2, 4, 6. So what I do after 6, let me add another one. Numbers dot add of 0. Okay. Then let me keep the statement here. Let's see. Okay. After the 6, I'm adding the 0. So how it retrieves or how it places, we'll see. If you see here, see, it is going with 0, it is placing on the starting point. So that's why we are telling the tree set is the one which provides the sorting order. So by default, it is ascending order. Okay. If you want any other sorting, you have to define actually. So let me show you what are the constructor types are there. If you see here, the comparator. So this is the function. So you can define your own comparator and you can pass that as the argument here. So according to that comparator sorting logic, it will place elements. Okay. So if you're not providing anything, by default, it works on the sorting order. Okay. This is about the tree set. The core difference is it provides elements on the sorting order. Okay. So let's go the differences. Okay. So now you got to know what and all the classes are there for under the set interface. Okay, those are like hash set, linked hash set, and tree set. So now there will be a lot of questions like, so under the same interface where duplicates are not allowed. So then how to choose, when to choose which one? So for that, here I have listed the total comparison. Okay, based on this comparison, we can choose. So how they work internally means the internal architecture of the hash set is it uses a hash map internally to store the elements actually. Okay, so linked hash it uses the linked hash map internally to store its element. Tree set uses the tree map internally to store its element. So it's the internal structure of all these set classes actually. So then order of elements. So hash set does not maintain any order of elements. But in case of the linked hash set, it is maintaining the insertion order. Okay. So elements are placed as they are inserted. And the tree set is the one ascending order by default, and it provides the sorting order. So the performance wise, if you see, hash set is the one which gives a better performance than linked hash set and tree set. Okay. So linked hash set is the one. This is also provides almost similar to the hash set. Okay, almost similar, but it's not exactly like hash set actually because it has to maintain this insertion order, right? So that's the order it has to do some funda like so the keeping the elements and maintaining the order. So that's where like a little performance goes. In case of the tree set, it gives like lesser performance than these two because so it has to compare the elements because there's a sorting order, right? So sorting order means it has to check. So already one element exists means if new element is coming, I should know like, so what is my comparator logic means whether it is ascending or descending. So accordingly, it has to compare and it has to swap the elements and place it. So that's why tree set gives the lesser performance. So insertion, removal, and retrieval. So for these three operations, hash set gives the immediately means 0 of 1, O of 1 means order of 1. So directly you can able to fetch it. Even linked hash set also gives the same one. But in case of the tree set, it gives the log n because it has to compare all the elements. That's why it will be giving the log n performance actually, the exact. So how the comparison happens means because we are mentioning that like all these classes does not support duplicate elements. So then how the internally the comparison works between the elements is, so it uses the equals and hash code methods actually. So as I mentioned before, so these two functions they use for comparing the elements. Okay, so like that, by using these two functions, it will identify the duplicate elements. Okay, even like linked dash it will also same. This also uses the equals and hash code. But when it comes for the tree set, it will not use the equals and dash code. So it uses the, because it is using the comparator interface, right? So either like compare or compare to methods actually. So these two methods we will see in our sorting class. So and also null elements. Okay. So hash set allows maximum one null element, because more than one null you cannot give, like it will go to the duplicate category kind. So even this is also allows maximum one null. But when it's come for the tree set, it does not allow even a single null element. Okay. So if you try to add insert, so it will give the null pointer exception, because on the top of this objects, it has to perform compare or compare to function actually. So that's why. So if you call like on the null, if you try to get anything, it will give the null pointer exception. That's why I have shown you right in the starting exception classes, runtime exception. So I define string str is equal to null, but str dot like size or get length, whenever I'm calling this directly, it will throw null pointer exception for me. Okay, and what is the memory occupation? So how much memory it takes. So Azure requires, it requires very less actually compared to all other, because it's a straight away array only. Uh, because it's directly Hashmap only it uses. So linked has said it requires like no uh, linked list also along with the hash map. Okay, that's why. So there is a storage for the hash map, and at the same time there is a some storage for the linked list. So it's a two storages actually required for it. So that's why it requires more memory than hash set. So in case of the tree set also it's a similar, because it is maintaining the comparator, right? For sorting the elements, even it is required for the hash map plus comparator. So it is also requires more memory than hash set. So now, so these are all the comparison all we have seen actually. Okay. Now when to use what? Okay. Their requirement comes like use hash set if you don't want to maintain any order of elements. So the major key factor is, so you have the requirement, so it should not allow duplicate elements. Then you will declare, you will decide for the set. So within that set, so now your requirement says that like I don't care for the order, so let it be any order, I'm fine with it. So in such cases, blindly we can go for the hash set, because the performance and memory and all are like no benefits for the hash set. And if your requirement says that like no, I need order, so whatever the order like no are the elements, so I need to retrieve in the same order. So in such cases you will go for the linked hash set. So and another requirement says that like, so I need to always like some sorting needs to be applied on my elements. So that is the way like my requirement demands. So in such cases you can choose a tree set. Okay, you can choose a tree set and you can provide the comparator, so whatever the logic you want for the sorting. So this is how you can decide within the set implemented classes. Okay, is that clear? Any doubts in set interface? If no doubt, like we can start with the map. Can I proceed with map interface? Yeah, you can confirm like, so if anybody is having some doubt or something, please let me know. Okay, I can clarify now itself. So list already we have covered. So now we will land at map. Yes, map interface. So as I already mentioned that this does not implement the collection interface. Also, the structure also it's completely different compared with list and set. So list and set are the one, it stores only the object. Okay. So there is complete object will be there. So even the integer or string or like character or like any customized object. So any kind of object, it can store as a complete object. Okay. But when it comes for the map interface, it will store as a key value pair. Okay. There will be some keys there, some values are there. So this we can use like the requirement says like, so there is some object is there. So I want to identify that object with some reference. So in such cases means whenever uh, okay, let's take like there are too many how can I say, okay, so there are like hotels or anything is there like, so if I want to identify that by using some reference, so in such case we'll go for key value pair. So by using the key here represents as the primary key. So like in database, right, wherever you are inserting any records into the database, so you should define one primary key for each table. So that represents uniqueness. So by calling the primary key, that entire row you will get it. So it's a kind of like similar here. So here the key represents the unique. Okay. So by using the key, I can get the values. So if you the keys are like indexes. So indexes or anything like in list, the indexes are integer. In map, the keys can be of any types. So the index we have seen already. Even though you are not explicitly giving in the list interface, by using the index ID, we were getting the elements. Correct, right? Get of one, get of two means first index element you retrieve, second index element you retrieve. So that was a default type was integer there, but it will not support any other type because while adding you are not defining, you don't have any scope for choosing your index type. So but when it comes for the map, you can choose your keys can be any objects. Okay, let's see an example like exactly how it looks and that. So let's see for the map interface. Okay, so as interface there are like set of functions are there in the map. So let's one is a clear. So all mappings it will get clear. Okay, and contains key. Contains key is the one. So you are having some key actually. So you want to check whether that map is containing that particular key or not. So in such cases, you can use a contain key. Okay, contains value. So similarly, like the value, but you will if you want to check like whether my map is containing that particular value or not. In such cases, you can go for this. So what happens if this is not there? So it has to retrieve, traverse through each element, then you need to compare. So if it is matching, then you will get to know, yes, it is containing. So instead doing all that stuff, so it's directly, you can check map.contains. So my map is containing this particular key or particular value. So directly you can get it. So entry set. So entry set is a function. When you call this one, it will return one set and it's a complete entries in this map. Okay. All the entries it will be retrieved. So getter is the one by using the key, you can get the particular object value. If you know the object also, you can get it. So is empty is the one, whether it is empty or not. And another is our key set. Key set means it returns a set only the keys. All the keys it will return in the set form. Okay. Put is a function generally used to add the elements to the map. Put all is the one. So if you are having already another map and you want to add all that map to another map, in such cases you will use as put all. So these two are same as add and add all in the list or set. Okay, remove is the one. So remove. If we define with a key, so the particular entry will be mapping will be removed. The size is the one. Like if you want to know the what is the size of the map, and values is the one. So which returns a collection of values. So if you see here, key set returns the all the set of keys. As I mentioned, it is a key value pair. So if you want to get only the keys, so that is a function called key set. And if you want to get only the values, so that is a function called values. And if you want to get all the entries, that's where entry set. Okay. So these are all the functions defined in map interface. So let's see. The first thing is hash map. So hash map and tree map classes are two concrete implementations of the map interface. Okay. The Hashmap class is efficient for locating a value, inserting a mapping, and deleting a mapping. The tree map class implementing sorted map that is efficient for traversing the case in a sorted order. So the map and set, the both the naming and the features of each name remains the same actually. They maintain the similarities. So what it is, so within the map, if you want to choose between whatever the implementation, let's see first hash map. So hash map here also does not guarantee any order. Okay. So similar to the hash set, because if you remember the hash set internal architecture is hash map only. Okay. Both does not guarantee the order. So another is linked hash map. Linked hash map is the one which guarantees the order, that is insertion order. Okay. There is another map which is tree map. Tree map which is the sorting order. It's a similar actually. So whatever the set is there, it's a similar everything for the map also. But only the difference is if you want to store as a single object, in such cases you'll go for the set. And you have the requirement to store as a key value pair. In such cases, you will go for the map interface. Okay. Let's see as examples. Okay. Here is the hash map example. So I have created hash map object here. So as I already mentioned, it's a key value pair. So key will be having some type and value also will be of some type object types. So here I have taken key as an integer type and value as a string type. Okay. Like that, I have created one hash map here. Then I'm printing like, so what are the elements and the mappings available in the hash map, because I did not add anything, but still like I'm just printing it just to see what is the values. So as I already mentioned, the add for similar to the add function for list and set, the put is the function for the map. Okay, put. So the key should be integer and value should be string. So I've given 1 1 2 2 3 3. So like this, I have filled my map. Then again, I'm printing the map just to see what are the elements in the map. So then we have already seen, right? Based on the key, you can get the value of it. So get of 1. So it gives the value of it. Okay. Similarly, I have told you, right? So if you want to get all the keys, so you can call key set function. If you want to call all the values, you can call the values function. And if you want like all as it is, the complete map you want to get, so you can call the entry set. Okay. So, and also if you want to replace any of the element within the map, you will use a replace function. So I'm replacing for the second key, the value as 4. So initially it was 2. Now I'm just replacing as 4. So then after placing, so here is the one, the actual iteration means I want to traverse through all my elements. So, so I'm getting key set, right? key set gives me one set it returns. So the set traversal can be like this by using the for each loop. So it can be by using the iterator or it can be by for each loop. So iterator logic already you have seen, right? So many of the places. So yes, it's the same set iterator. So like this. So when I call the key set, so it returns one set with the all the keys. So that either I can use the iterator for traversing through, or else I can use a for each loop. So because already iterator we have seen couple of times, so that's why I have taken the different as for each loop. Okay. Similarly, the values also I'm traversing. And the another thing is the difference is, so as I have shown you key value pair, right? So actually the map implementation uses the entry class. This is a static class which is available in the map Hashmap class itself. So that is storing the actual entry. So all are like array of entries actually. So array of entries, the Hashmap will be holding. So if you want to retrieve entry by entry, so entry is the object. So all are like entry objects. So entry of key value. So we'll give the all entry set. Entry set gives the set of entry object. Okay. So I'm traversing through the set of entry objects. So based on that entry. So if you want to get entry dot, so if you want to get like the complete entry, I can print like this. So and another thing is, if I want to get only the key, so there is a get key, so which gives the only the key. And if you want a value, I can get the only get value. So like this. So if we have any map and it is having like no, say, I mean many mappings inside it, and you want to traverse through that particular map where the each entry, each mapping is by using this entry set function that returns the set of entry objects. Okay. So that I can traverse either by using the iterator or for each loop. So each entry object that will be having two fields, key value. So there are the getters for that, which is get key, get value. So I can get individually whatever I want. Let me execute this one. See, we'll compare map. Initial as map. So because I just created, I did not add any elements. Simply I'm printing. So I can see it's empty here. Then after that I printed 1, 2, 3. So here I can see 1, 2, 3. And based on the value I'm getting. So key, get of key. So what is the one? 1 here. So after that only key set. Key set means only the keys it will give. 1, 2, 3. I can see 1, 2, 3 here. Then after that, what I'm doing, only the values. Values are 1, 2, 3. Values are here, values 1, 2, 3. So after that, what I'm doing, key value pair I'm printing. So that is 1 is equal to 1, 2 is equal to 2, 3 is equal to 3. Generally, the elements are stored like this. Okay. So after that, what I'm doing, I'm just replacing 2 with 4. See here, 1, 4, 3, 1, 4, 3. You can see here. So while in the traversing, I can see the 2 is not there from here. So it is replaced with the 4 value. Okay. That's how hash map works. So the another thing is contents is also one more thing. How we can use that is numbers dots. See contents key. Let me check for whether the 2 key it is containing or not. So these are Boolean. I can represent in the condition. Key exists. So like this, we can call for compare, I mean, contains value. So anything like we can do. So where it is, I'm not printing in proper place. Numbers replace to 4. Let me write debugging where it went wrong. Key not exist. See here, key exists. I'm checking for any key is present with the value of 2. So because it is already present here, right? 2, 2. So that's why it is giving key exist like this. We can use the contains key. So and remove also similar like, so based on some key like now I can remove any of the elements. So another use case we can see here is there can be the program like let's take they had given one string, big string. So let's take Java is a good programming language. In that, if somebody asks you, tell me how many times each character repeated. Okay. So how many times each character is repeated? In such cases, for the calculation sake, we can use map there, hash map. So here the key will be the character. So we are looking for each character. So and the value we can keep as the number of occurrences of that particular character. Okay. So this is the one use case like you can see. This is a basic kind of program. So how many times like no each character occurred, then what is the larger size means more number of times which character occurred. So these kind of questions, right? There can be programs. So all such places we can use the hash map. So any doubts in this? Okay, with this I would like to stop. Chandrasekhar, like can you stop recording?